Hey everyone, this is Jojo. Today I would like to share the book The Gamer's Brain: How Neuroscience and Game User Experience Can Impact Video Game Design. I got a minor in neuroscience in my bachelor's degree, and I choose this book because I'm curious about how we can apply the knowledge of neuroscience to game design.
To understand how to apply knowledge of neuroscience to game design, we need to fully understand how our brain processes information. Here is a very simplified chart of the process. Basically, information processing usually starts with the perception of an input and eventually ends with modifications in memory. However, keep in mind that in reality, these cognitive progress are entwined and do not occur strictly one after the other. And next question is, what is perceptions and how does it work? Let's take vision as an example. So when you look up at clear skies at night, the stimulus received by the receptor cells are all about physics, orientation, spatial frequency, brightness, and so on. Then the brain processes the sensory information to make sense of it. And that process is perception. The last step of information processing allows an access to semantics, to cognition. Let's talk about an applications of perception. It is called Gestalt laws. So the principle of proximity states that elements that are closer to one another are perceived as being part of the same group. For example, in the below figure, the dots on the left are perceived as being part of one group, but on the right, three separate groups of dots are perceived because of the added empty space. Here is an example of Far Cry 4, a first-person shooter game developed by Ubisoft. In the front-end menu, the Skills tab allows players to spend skill points. The first time players discover this interface, they might believe that skills can be bought one after the other on the vertical axis. After all, many skill trees in games with role-playing elements behave that way. You unlock them bottom-up or top-down. However, that's not how the skills work here. You can buy tiger skills from right to left and the elephant skills from left to right. If you look more closely, you might see some small arrows indicating which paths you need to take to unlock skills. So, by applying the principle of proximity, we can help players to quickly grasp how to unlock the skills simply by placing the dots closer to one another on the horizontal axis and by changing their shape a little bit to infer orientation. It takes up the exact same space in the interface, and we can remove the subtle arrows that are no longer necessary. So let's summarize perception for a little bit. We know perception is all about process input, and the limitation is that perception is subjective and biased. And we mentioned to use the Gestalt laws to solve some of the perception problems in games. The next thing is, what is memory? So remembering something implies retrieving information that was previously encoded and stored. So memory is not only about the process of storing information, it includes these three steps: encoding, storage, and retrieval. A popular model of memory in psychology is listed here, suggests that there are three components for human memory: sensory stores, short-term store, and long-term store. So what could be some of the limitations of memory? At some point, players will inevitably put the game down to go on with their own lives. If they do pick up the game again, the time that has elapsed since their first game session could range from a few hours to a few days or more. When the player finally resumes the game, the system does not usually take into account how much time has passed. During that time, the forgetting curve occurred and some amount of information learned during the first game session was lost. What happens then is that there could be some discrepancy between the player's skill level and the challenge level reached at the end of the last game session. Players might have forgotten about some game mechanics, controls, or objectives. Let's see how can we solve this problem. So for example, in the open world action adventure game Assassin's Creed by Ubisoft, the HUD always provides a contextual mapping of the controls. This allows the players to know exactly what actions they can accomplish at all times, but also how to execute them because the information is displayed in such a way as to mirror the four-face buttons of a console controller. They never have to remember this information. This HUD design alone reduces players' memory load and provides any storage or recall deficit. So we know memory is all about encoding and storage, and the limitation is that it has forgetting curve, but we can use some methods to reduce the memory load to solve that problem. So what happens in information processing? Here we take attention as an example. So pick one card and remember it. I can guess which card you picked and make it disappear. Well, the thing is that actually all cards have changed. I've shown this picture in the previous slides, but have you realized that there is a cute northeastern husky over there? So in short, attention allows us to concentrate our processing resources onto selected inputs, but by focusing on specific targets, we may ignore other things. Red is a good color to draw attention to critical danger scenes. Here is an example in Apex Legends. When the player takes damage from the enemies, there will be a red mark to show where damage comes from. Based on the amount of damage, the size of the mark will also changes. Therefore, players are instantly informed that they are in danger with minimum workload. So, in summary, we know attention is about spotlight, and the limitations are inattentional blindness. And to solve that problem, we may use minimum workload.
Then I would like to point out some of the ideas that I would not agree with. Firstly, I think this book is more about behavior and cognitive science rather than neuroscience. The aim of neuroscience is to understand the fundamental properties of neurons and understand the biological basis of learning, memory, and perception. However, this book introduces more about how to improve player experience by using psychological methods. Secondly, a few concepts in the books are a bit outdated. For instance, in chapter 6, Motivation, the author mentions the theory of flow, which refers to a state of enjoyment when one is totally engaged and immersed. However, this psychological definition was put forward in 1990. Since then, many researchers have tried to think through what does flow mean in game experience. For instance, in 2005, Switzer and Wyeth created a new game flow model. It consists of 8 elements: concentration, challenge, skills, control, clear goals, feedback, and immersion and social interaction. Each element includes a set of criteria for achieving enjoyment in games. I think it would be beneficial to incorporate more updated game research into the books. Overall, I highly recommend this book to you. If you want to think the game design from a cognitive perspective, I'm sure you will learn a lot from this book.